Hello? Do you have the Wi-Fi code for me, please? Yeah.
Joaquin, just be aware you're unmuted.
Oh, sorry. Is my sound okay?
I got you loud and clear.
Excellent.
Joaquin, this is David Green. Are you still on the line?
Yes, I'm ready. Can you hear me okay?
Yeah, I can hear you okay. Just I sent an email to you this morning to reach out, so just wanted to say hi. Perhaps you can follow up.
Thank you, David.
Thank you.
I'll try. Yeah, it's in the middle of training here with California and Sacramento, but yeah, I'll follow up with you as soon as I read it.
Okay.
Thank you, Dave.
All right. Bye-bye.
Bye-bye.
Hi, everyone. We'll be starting up here again in a few minutes. But for those of you who are presenting in the next session, if you're online, I was wondering if we could do a quick sound check now, so we don't have to do that later. Joaquin, we heard you loud and clear. I think you're good. Brian Collins, are you there? And if so, could we do a quick sound check with you? If you're speaking, you're on mute.
Hey, Birgit, this is Everett. Joaquin and Brian were going to present from their end, so they're going to share their slides. So I know Joaquin's on. Let me check and see if Brian's on, but
Okay.
let's see.
We still got a couple more minutes.
Yep. Yeah, it looks like Brian Collins is logged in.
All right.
And I know that Joaquin is on as well.
Yep. Heard him clearly before.
And then once they're done, I'll pick up the slide sharing again and as you host there.
All right, sounds good.
In this first slot, because there's two people speaking, I had it set at 25 minutes. I'm sorry.
Hey, Everett, this is, sorry, go ahead. I'm sorry.
I was going to say I have that time slot at 30, but that sounds like Ed Freeborn.
It is. Hey, did you say that PK had, or the system-wide safety meeting report was on the NIROPS page?
Just his presentation.
Oh, okay.
But we can see about getting the actual report.
Yeah, I'm not seeing his presentation either.
So Brian or Joaquin, if you want to go ahead and share your, I'm going to stop sharing here. So
Okay. I'll be the sharer and the slide flipper for the both of us.
it's good to see you again, Brian.
It's great to see you. Wait, hold on. Going for the button. There we go. All right. Can you see that, Everett?
Yep, it's all up there.
All right.
Yeah, and you guys get the award for the largest file size. So that's in the mail now.
I was going to say, I knew this is a remote sensing meeting, and file size and pixel size is everything. Right? You just got to have, it's got to be hard. It's got to take up like 800 gigabytes to download into your thing when you're in the field. Just kidding. We have some really great animations that Joaquin has, so we really want to make sure we can show those. So thanks for working through our slideology to get it so we can show it.
We're looking forward to it. And now that it's 15 past, I think we'll go ahead and get started with this last block of the day. And the focus of this one is going to be decision support tools and EO applications. So our first slot will be two speakers, Joaquin Ramirez and Brian Collins. So thank you, welcome. We did a sound checks here, so we know they're all live and good, and they will be driving their slides. That'll be a half-hour slot. The other ones after that will be 15 minutes each. I will, for this talk, when you're about a 5-minute warning, what I'll do is I'll go ahead and turn on my camera, and so that you'll know that's a visual cue that you're at 5 minutes and it's time to wrap up. So with that, we'll hand it over to you. Thank you.
Great, thank you. And thanks everybody for having us brief. This is a unique one. This is two companies briefing together to the TFRSAC audience. I know both Joaquin and I have been around this audience for quite a long time. And thanks all for your time and the chance to talk to you about things that we see from the decision support side that can fuel a lot of the tech discussions that you have. My name is Brian Collins. I'm the CEO of Intera, and I will be splitting time with Joaquin Ramirez, who will also speak. We'll try and make it pretty smooth. We changed the title of our presentation to Leveraging Remote Sensing Data, and our perspective is coming at this group from the decision support side. One of the things as we walk through is a really great opportunity for the two of us to talk together. We are two companies working in the wildland fire space, and we collaborate, and we wanted to be able to talk to the community about what it means to work together as advocates for the whole community. And I will now turn it over to Joaquin, so Joaquin can introduce himself and walk through a couple of concepts.
Hey, thank you, Brian. Yeah, my name is Joaquin Ramirez. I'm the CEO of TecnoSilva. We've been working in this arena for over 25 years, and with something we've learned is this business is so complicated that it's all about collaboration. It's all about an integration. So you can switch to the next one, and this is a great opportunity to do it together. So we really appreciate and thank Everett and Vince to give the opportunity to do it. Okay, so we are technologists, right? And that's something that we really wanted to make clear, that we're here to help in such a complex topic, that such a complex problem that we have to fix together. Our friend Natasha Stavros used to talk about this wicked problem. It's an all hands job, and our role as technologists is to work with the best science possible, with the scientists that try to answer the questions, to the users that really improve the processes and use the applications and give us the feedback to us, that we'll try to do is to bridge the gap between that complex science, try to use the best technology possible and create tools and make that triangle, we love the fire triangles in our arena, to make everything go smoothly, because it's not just the science, it's getting the voice from the users and make this a continuous improvement process. That's one. So, well, we as companies, we are really want to know that what we're facing, and actually we're going to have the conference in Pasadena next week. We're in a growing problem environment, and right now those problems are going faster that we can apply the solutions. So the technology has to be really focused on reduce the friction between the technical silos that are out there. We need to focus on creating standards to improve and facilitate interoperability. We also have to solve the friction on the social side. So, well, we have to communicate efficiently to our customers. We have to communicate efficiently to society. We have to be really very good at data sharing and moving from data to information, and just try to break those potential silos. Well, oh, this is just my information. Nobody can have access to that. We need to be able to be good at that. And finally, we have this adoption friction concept that has to make us go from the, okay, there's a pilot project, so what does it mean that it's a technology and tools and science that is going to be adopted in a sustainable way? How we're going to improve our processes, how we're going to treat our people, how we're going to make our people own that data and relevant intel and apply it in a sustainable way to improve the processes. That's one. Yeah. You getting this one, Brian?
Sure, I'll take this one. Thanks, Joaquin. And again, I'm Brian, and I come from Intera. And when we work together, Intera and TechnoSilva, and actually when we work with any companies and all of the industry that works together, a couple of things we're bringing to the table. Operational expertise. This is really the key to where the blend that TechnoSilva and Intera brings is Intera and TechnoSilva share this operational expertise of understanding intelligence, operations, output, outreach, and the execution of the fire mission. We both come from that in different perspective. From a technology expertise, that is from when you see later from Joaquin, the fire science technology is really the big technology that TechnoSilva brings. It is a core competency for them. And from Intera, it's the data integration and the collaboration side and integrating it and bringing it to a decision. So we blend together in that technology side. Science is, of course, something that we look a lot to the academic area for. That's what from a companies, we bring the ability to merge those, but we also leverage a lot of the science. And social is really the key thing that we also bring together because of our reach into different communities, which is blending together parts of the wildland fire community. And I think as you start, when you move from the technology level into the execution level, you start realizing that as much as there's silos in technology, there are silos in how the wildland fire community has been structured and works ahead. And we're starting to see that technology developed for one area can have a huge impact in other areas, and we've got to get past this social bridge between it. And from a company perspective, we, Intera, TechnoSilva, and our partners as an industry, we are here to help bridge that social gap if there is a gap that's hard from technology to bridge, because we touch all these different areas and we do it as industry, but we can serve as a bridge between different areas. As we talk about technology and really leveraging remote sensing data, there's also a piece about what the agencies and TFRSAC can do is how do you bring together these communities together? And we came up, Joaquin and I sat down and talked, and we came up both with us talking and also with Kate Darden from Intera and all of the TechnoSilva staff. And what are the key things that we think the TFRSAC can really leverage moving forward or press on? One is the interoperability side, which is the data integration standards and APIs. As technologists, the more we have to chase APIs between us it hinders technological advancement. And I'll give you an example. If you're a small company bringing a new technology into the fire space and you have to figure out or custom build to something, one API for one place, one API for another. That's a huge burden for a small company that's really focused on, for example, auto processing hyperspectral or multispectral data. They're great at that. They want to focus on that. We need to give them the capability to exchange that data with other people without them having to invest in an entirely new capability that maybe wasn't their sweet spot anyway. The other thing is company interoperability. This is us, the challenge to industry. It's how do we think together? How do we work as a team? The old worlds, again, we come from fire. The old worlds of a monolithic CAD are gone. Today's technology and industry world is lots of collaborators working together, a team. You'll see that in a few minutes. That is how we're going to work faster. And as the TFRSAC, the more you can encourage that, the more we will work in that direction, right? It's not a one size fits all, but we all win if we start working together. Another place is agency interoperability. One of the big places that we can always hit a hurdle is when policies and standards set standards between agencies limit the exchanging of data. What will happen is technology will mirror that barrier. If there's a barrier at the agency level, all of the entire industry and technology community can come up to it and try to work around it, but we have an extra point of friction, which is how do we set standards and policies and even training systems at the agency level that encourage us to work together. And the last one is effectiveness interoperability. It's a term I created, which is we have to start looking at how the effectiveness of a piece of technology can jump between one particular mission and another. An example is things like remote sensing's contribution to operations. It's where everybody lives today. But the other side is there's a huge contribution of remote sensing to prevention and mitigation. How do we bring that and make sure that community is leveraging that same information? And then even between mitigation and ops, and this is not necessarily a TFRSAC, but we need to remind ourselves that doing work before a fire is kind of part of operations anyway. If you can prevent something from happening or change the conditions so when it does happen, it's less bad, that is the same as running a dozer line at the point of ignition. You can have done something in advance. That's essentially contributing to the operations. And what you do in operations feeding back. So these are the 4 areas you'll hear us talking about as we move forward. Oops, I went backwards in one slide. And now what we'd like to do is talk a little bit about how we come together as companies and approach this between both Intera and TechnoSilva. Joaquin has a lot of technological stuff that I really want to make sure we have time for. So I'll go very quickly through Intera. And the purpose of this portion is to remind that while we work together as companies, there's places where it looks like we do the same thing, but we're partners as we work together along with all of our industry partners. And you'll see an example of, we all have areas we have expertise. We all work together in areas, and the problem is big enough for us to work together and move ahead rather than sort of one size fits all and try and solve every problem. You'll see a slight overlap, and so we talk a little bit about where TechnoSilva and Intera came from. Intera did come from a common operational picture world. That's where we focused in 2010, and it was for wildland fire common operational picture. The lesson we learned right away was common operational pictures are for looking, decision support systems are for doing. And so we very quickly realized we would be tailoring our system, not necessarily technologically, but in making sure the data was presented to a user for specific functional areas. Pre-planning and mitigation, operations, incident management, and analytics and reporting. And that was really key to us. And I think the community is starting to realize that today. And this is where company partners came around. Because when you were a one size common operational picture, you wanted to do everything in the world. As soon as you start tailoring towards decision making, Then you come to a situation where a particular agency may use the pre-planning solution from Intera and merge it with an incident management solution from Tablet Command and a modeling solution from TechnoSilva. Suddenly you're attacking a decision and you're not buying one piece of software. Quick snapshot of the fact that the wildland fire community at the industry level probably collaborates more than you think. This is a matrix of the people that we as Intera touch routinely in the course of a week or a month. And you can see it ranges from peers and companies that work together to dispatch companies to interagency work to big giant technology companies who build hardware and launch it into space. All of those people talk together on a routine basis. That is, in one sense, your industry is very collaborative, more so than my background, which came from the defense world. This is a very collaborative industry that you have. At the same time, agencies work very well in the and fire. We know this from Intera. We came from local and moved to federal. All of our local agencies to the federal agencies and helps encourage that communication back and forth. There are vendors who are very, very focused on the federal side. There are people in the middle. This is an area that, again, that we see that as industry, but also at the agency level, this is critical that you get the local perspective up to feds and back down and work very fast, because there has traditionally been a big silo in between these two. Finally, sort of talking about some examples is going into whether it was the effective interoperability or IDEA interoperability. This is I'll give a couple examples of sort of how we've plugged together and moved together from a common operational picture to more decision support using mainly remote sensing examples, and then highlighting something coming up every year, which is the fire school in San Diego. But most importantly, one of the key things to look at, particularly in remote sensing, I think it'll resonate, is programs that appear similar at the outset. If you sit back and look at the FIRUS program, which was real-time in remote sensing data linked directly for initial attack and fire modeling behavior, and you relate that, if you look at it, it looks like, hey, it's real-time imagery coming in, and I'm looking at video from an aircraft, and it's in a geospatial context with my suppression activities. And then you look across to the state of Colorado with their multi-mission aircraft, and you say, that aircraft flies and has remote sensing data and flies around the state. And Oregon has a similar program with which is being built up in their ability to have a remote sensing aircraft linked to a decision support system. Those things look very similar from an outset and a technology perspective. They're very different in an application and why in a culture. And one of the key things is those programs learning together of how you learned what was useful from one that went to the other. And at the same time, how does the TFRSAC sit above that? For example, ZAC, when ZAC is looking at requirements of why and what did FIRUS do well, why and what did Colorado's MMA do well, and Oregon's program do well, so that the whole industry can move ahead. On the mitigation and effectiveness side, I mentioned this earlier, which is planning and mitigation effectively is part of response, and response is part of mitigation. I'll give an example of what's happening today in that world, but also the gap and the lack of remote sensing data that's prompting into that should be leveraged. So first thing, we'll talk a little bit about that, the remote sensing world, the tactical remote sensing world of FIRUS, which is in the upper left, the Colorado MMA, upper right. You can see, if you sit back and say real-time video flowing, very similar systems. The intent was different, and the two programs are now learning from each other, and Oregon is learning from this because they have a common language now to talk of what and why was FIRUS. FIRUS very focused on initial attack, the first 10 minutes of a fire, getting both remote sensing data as well as a fire model to make a tactical decision about resources. Then there's the MMA program, which was a statewide program in a state that has a large area of unattended areas, low population, and then densely clustered populations with a very different wildfire regime in that. So the Colorado program was, we don't have a lot of resources. We need to know what's happening in our state to allocate those resources. So the program is very much built about an aircraft system that can cover large areas of space, move through the state, and support the entire state in a very rapid manner so that you have a lightning bust in an area, you can get a quick triage of it. And so those two programs look the same, but they have slightly different applications, and they're leveraging back and forth their technology. And now they can interoperate with data. So if you're in a Colorado decision support system, the COWIN system, if they ever flew to California, those same operators would be able to see the FIRUS data. If you're in the California system and architecture, if you're in FIRUS, the Colorado aircraft flies in your area, that aircraft suddenly brought in, it's another tool within the FIRUS architecture. So we're starting to see that move across. On the lower right side of the screen is an example of, and this is actually integrated to FIRUS, of the ATAC architecture plugged into FIRUS. So both of those programs have leveraged the ATAC architecture to exchange that same remote sensing data with another decision support platform, very much focused on ground operations. Starts learning about how we learn and exchange and move beyond this one-size-fits-all world. And if anybody has any questions for these examples, and I think the TFRSAC is staffed, attended by agents, by members of each one of these agencies. I do want to highlight the middle chart here, which is the world of infrared remote sensing often has been thought of as, the IR aircraft that flies late at night and covers a map. But those aircraft, an example here is Courtney Aviation's aircraft, the capabilities are so much more robust than they were in the past. They have an operational construct too. So as that data flows through, it can be integrated in a similar type of architecture. And we do that today through the EGP and the California systems. And then finally, when we start talking about effectiveness integration to wildland fire risk, in addition to landscape level risk, I'll highlight an area that I know the ops and risk communities are starting to share data very rapidly. This is an example of Oregon that has a large number of parcel-based risk assessments and local data that is available to an operator when a fire happens in that area. They can immediately access electronically if there have been home inspections, is there a parcel risk assessment? They can use that in their operational decisions and help weight their decisions just as well as having a rapid wildland fire model. What we're really looking forward to from the TFRSAC is what remote sensing information can feed this process as well as the suppression mission. And that is sort of a challenge I'll ask, because we're not a remote sensing company, we're a data decision-making company, is how you can throw some efforts into that, because that is an area that is just as important to operations as the response function. And with that, I'd like to turn the rest of the brief over to Joaquin, so Joaquin can talk about operationalizing wildland fire science.
Yeah. Thanks for the ride, Brian. You really landed into the perfect spot. Antonio Silva, we're a team of about 75 people. We're not a startup. We started 25 years ago, but we have been focused always in trying to operationalize or make the wildland fire science the best available possible, the best data possible to make it operational. So next. Yeah, we've been working with agencies. We've been working with research institutions from the last since 1997. Right now, we're about to publish our latest 30th paper in the last 2 years. We're trying to share also that science. We're focused just on wildland fire community, whether it's supporting incident management, the risk forecasting, and also the wildfire protection planning too. Next one, please. Although I'm going to show some examples from California. As a company, we work worldwide. We have our systems implemented in Southern Europe, even in Netherlands. Imagine that Netherlands is concerned about wildland fire too. But in the US, we work on the many states on the south with our fire response incident management system and dispatching system, and in the west. And for utilities and wildland fire agencies, we're working mostly with the modeling. Okay. Right. To make the technology operational, we need to work also with another triangle. How we make that technology operational? Well, we need 3 components. First, talking with the scientists, we need to work with models that are field tested, that are approved, that are embraced, and also that are trained. it doesn't work to have a new machine learning model that just appeared yesterday, because that is not the whole solution. We have to prove those models, share with the community, get the feedback, and make it operational. Then we have to provide actionable data that is seamlessly integrated, as Brian mentioned. We need to use data on our models that are affordable, that are accessible, that are on time. And when we have a new sensor, there's going to be a process to match the sensors and the data that is coming there to a better models that at the end of the day give also the right amount of actionable information. We cannot intoxicate our users with too much. We have to provide the right amount of information in the right place. It's going to be different if you have the time for we're going to do a prevention of medication project or a prescribe burn, where we can plan our actions, whether, or on the other side, where on an initial attack incident with that valuable information has to be delivered in an actionable way, or if we're in a standard attack incident where we have too many resources and the complexity is there. All of them needs best data possible, best model possible, and results that are actionable. Next one, please. I'm going to go through some examples based on the study case on California. We're going to show the warfare modeling technology solution. We were selected among 131 companies in 2019, and we've been implementing this solution. Next, to provide initial attack intel first, initial attack modeling. It provides also 4 days of forecast of wild and fire risk every hour, and also integrate that information into an state COP that also could share information with the platforms that Brian showed us, because it's not only CAL FIRE, it's the federal partners, also the local partners are important to also consume that information. Next. I'm gonna go through the flow. Basically, this is a video showing live how we, I don't know if the play works. We integrate with it's about the integration. So we integrate with the dispatch. And as soon as we get integrated with the dispatch, we have in 30 seconds, an assessment of that project potential impacts. How many houses could be impacted? How many buildings can be impacted? That information provides the direct initial attack assessment of that fire. It's very easy, 1 to 5, how complex that fire can be, providing all the intel to anybody that is involved, from the unit that is on the field to the people that is at the GAG level. Next. One important thing is that we don't have hours of time to get a simulation. Although we're integrating, for example, the warfare fire model from our friends in San Jose State, the simulations that we need to provide have to provide that information in seconds. And it have to be provided in a way that is actionable and easy to digest. So having those impacts with all the fire behavior outputs that are needed in seconds is key. And we do that in a 4-dimensional environment, because fire is 4-dimensional, is space and time, right? That helps to understand the complexity of the interactions between the terrain, the fields, and the weather that is expected for that moment. On next, we're running a high-resolution weather model. We're working with the best fields data possible, but also we're integrating valuable data coming from AI and remote sensing, for example, from the Landscan dataset for population, or for the Microsoft Buildings dataset, and integrating others to be able to see when a home could be impacted and how many of them could be impacted. So, for example, supporting ECMA processes, etc. Population, buildings, or critical assets. Next one. The potential of every fire. We know when the fire starts with 1 hour, but what they may do if we have 10 fires at the same time? Well, we need to know the conditions about the fire behavior, the terrain difficulty, what is the growth potential of the fire. All of that, it's delivered in a very simple way with very simple metrics in the same environment, and also shared through mobile apps to the units that are going to the incident, so they know what they're facing while they're driving to that incident. Next. The detection of technologies, whether it's coming from hotspots from satellite, but to be honest, one is that's been a game changer for us, integrating the FireGuard information. Here we see a couple simulation that goes together with the wonderful work that's been done with the FireGuard, where we know now every 10 minutes what is the fire progression, that help us not only to validate what is going on with the models, but also calibrate the simulations on the fly. And our platform allows to do real-time data simulation and calibration of what's going on. Next. that's been a really game-changing technology for us. We use hotspots, but now this is changing everything. And everything that comes from Fires and everything that coming from those platforms is going to improve that. Obviously, wildfire modeling is quite complex, so including the more advanced models, like for example, with Ninja in collaboration with the Missoula Fire Lab, help us to refine the inputs for those models that will keep on improving. I mean, we're waiting for new models coming from machine learning. We're building ours. Others are building others. The Missoula Fire Lab are building others. We're using this same technology in Chile. We're using the same technology in Europe. But it's all about having good data that is delivered in real time. And this is an example of integration of complex modeling in the same environment. Next. Yeah, let's go to the next one. I think that Bridget is here, so we're gonna raise a little. We are not only running one simulation. Every day we're running 180 million simulations with those same inputs data, so we can provide the intel that the units need to set up the preparedness levels and calculate on all those 180 million simulations, what is the potential size of a fire that it starts there 4 days in advance. Next. That could be beneficial for communities too, for anyone. Real-time tracking of resources, real-time tracking of cameras, everything in the same environment. Again, it's about the integration. Next. So the platform has been used very intensely and has been supporting on all these incidents. We started in 2019, and guess what? We had 2020 and 2021, the worst fire season in a row in California. Next. And I will go I will end on my side with the validation. All this science needs to be validated through the BIR sensors. We were able to evaluate the 2025 season where we see the fire radiative power that we had in the month of September 2020. That was the most active by 4 times energy that was emitted to space. And that was when it was evaluated. Go ahead. We were able to predict the fire activity with their fire size potential and 19th percentile 4 days in advance on those peak days that we have on August. That's operational validation with remote sensing at that scale. With the FireGuard, it's not enough. Next. But right now, we're moving into validating the fire models with the FireGuard data. That's the best remote sensing data that is giving us what the fire is doing right now. We have a paper going on that is going to be presented in Pasadena with the validation of more than 1,800 fires, with the actual fire progression and the actual prediction and what the models tell us how they can improve. Next. We've discovered that, as we know, there are some models that they don't work, and most of the timber models on initial attack with the actual fire models don't work. So we're addressing that with some machine learning techniques, next, to improve the actual operational models. Because again, in this case, we can see how, thanks to calculating the rate of spread in real time, we can tune the actual models to provide a better results and again, make this circle keep going. Next. With remote sensing too, to provide, we were filling the gap of 2 big inputs that were missing on the fire modeling. One is the live field moisture, how the vegetation is there, how is the vegetation performing this fire season. So we created a machine learning model with the national data field moisture database and MODIS and some other variables to provide a continuous layer of woody field moisture and herbaceous. Next. And also, how is the vegetation? Well, the vegetation, we have to know about the vegetation. And by that, we're using the USGS LiDAR together with the GDI LiDAR that is coming from the International Space Station, but also getting the granular information that we can get with drone LiDAR. We do that every year, updating every 4 times a year, all the field models to get better inputs. Next, and I think I'm ending with that one. Just the technology is not enough. We need the users for a better future. This is not only the technology, this is more than the 40 people that is in the Intel militia of Cal Fire that is making this move forward. With that, I'll pass it to Brian.
Thanks, Joaquin. So thank you guys for the whole organization, TFRSAC, for letting us give us a chance to talk from a company perspective. We know one of the things and the reason we put so much effort in this is the problem we have is pretty large. It's larger than it's ever been, and I like to always highlight that when you talk to someone who a local initial attack incident commander. And particularly in any of the states that we look at today, even as we move into the East Coast, because the fire regime is moving, is the decisions that are made by the first on-scene initial commander today have the scale and tempo of what we used to think about 5 years ago, 6 to 12 to 24 hours into an incident. They'll have, particularly in some of these large scale fires that we're moving, they move so fast that we're already sending 30 apparatus towards a fire when the first incident commander is doing his size up. And that incident commander is the one everybody looks at that says, move, where should they go? Where do they stage? So that type of decision used to be made by an IC, a type 2, type 1 IC. Now it's made by the first person on scene doing a size up. So we really need to think about how we bring all these capabilities to that, to know in advance how to prepare for it, set up the conditions in advance, and then use all of this stuff, that whether it's remote sensing data, whether it's modeling data, whether it's mitigation efforts, to help speed up that decision process, and at the same time not flood them with information that they just can't handle because they're standing on a hill looking over and worried about where those 30 resources are going to go, not just the 2 they have, as well as evacs.
Thank
And
you so much.
Yeah.
We're over time.
Yep. I got it. We had a lot of slides, but thank you guys for listening to us and being a receptive audience.
Thank you so much.
Thanks,
that was
everybody.
Totally information packed, and I'm sure people are still. I'm sure there will be follow-up questions, and in fact, there was one question in the chat that I will read out to you. If you can give a quick answer, maybe as we switch over, as Everett takes back control and starts presenting slides again. And Everett, you have your hand up. I don't know if you have a question too or something you want to say.
I just had a couple comments there. I wanted to thank Brian for putting that "what can you do" slide in there. That type of challenge is exactly the type of thing that we need as feedback. And also to Joaquin for there was one slide in there of the FireGuard data that showed the progression vectors in it, and that's something that I really like to see. So that was my only thing, and I'll take my hand down here.
All right, let me read this question real quick, and then as Everett switches over, maybe you can give a quick perspective. And that was mainly directed to Brian. It was from Dave Jones. How do you approach interpreting the disparate data sources so that you're not placing data that is too complex in front of non-technical experts? I think that's something all of us could contemplate.
Yeah, that's a great question. And that is kind of where we are as a decision support system. That's our focus, right? So the first thing is we focus on the decisions that the folks using our system are going to use. So we try not to, so for example, an Intel person who's in an Intel workspace, their decisions are different. So we're giving them data that is focused on that decision, as opposed to an initial attack incident commander. There's very certain things that they're going to look at. So first is knowing the decision they're going to work on. And I think that's an important thing that I think I know that Zach and Sean are working on the decision matrix of what data should be available for someone at what level to make a decision. That's the place we need to be. The second thing I will challenge is the fire operators are really smart. I come from the military side. The first time I went to a fire and had a fire operator tell me about what a MODIS pass was and whether that hit was a good hit or not, it was from a fire operator. It wasn't from somebody who flew satellites, because they've been looking at MODIS and VIIRS data their whole career. So I also challenge the other side is huge ability to master and process information. An example of the amount of training a hazmat crew has to go on a hazmat would just boggle the mind of someone who doesn't know about the amount of training a hazmat crew has. That's true across the entire fire industry or fire workforce, even from wildland fire to fire behavior to a metropolitan strike, someone going into an apartment building. So I don't know if that helps, but that's kind of the approach we have.
Thank you so much. And again, thank you for your time, both Brian and Joaquin. And we are going to move on to our next speaker. I see the slides are up. And we welcome Steve Ambrose, who I believe is the Chief Climate Scientist for SAIC. And so, Steve, can we do a quick sound check with you?
That's correct. Can you hear me?
Yes, we can. Thank you so much. And I will give you a 2-minute warning by turning my camera on. I'll disappear here momentarily.
All right. Yeah, I'm Steve Ambrose. I'm at SAIC, and my team here, Sean Nolan, John Everts, John Temler, have been very helpful in pulling this together. I'm going to be talking about a few things here, going through a series of things that we're involved in and projects that we're growing and things we want to do. that we think will improve wildland and wildfire planning, response, and collaboration. So next slide, please. We talked a little bit about this at the last TFRSAC meeting, this quantitative complexity management technique that we have access to and learning about too, and as well as applying it to many different things. It's a model-free approach that quantifies the entropy and correlation of system interdependencies to identify system anomalies. And that's the thing here, the criticality, the anomalies, the things that this system can see. It's also called artificial intuition, and it's a standalone capability that it can work with AI and ML, but it's not AI and ML, so it's very different. It can work on smaller data sets, fewer data sets, and it shows the changes that are occurring from whatever imagery is utilized, whatever data is utilized. It's also been used in the medical field, for instance, of looking at brain scan data and anticipating seizures. It can see those anomalies coming away to pay attention to patients. That's the kind of way we think about it in terms of the wildfire and wildland fire issues, is what's happening within the environment that's changing. It could be associated with temperature, rainfall, wind speed, drought, soil moisture, anything that can be thrown in there to look at the image and see the complexity and something that's about to occur. So it gives you a kind of a pinpoint to things that are about to happen. Next slide. Okay. Can you go back one? There we go. So this analysis of the complexity of the foliage in Southern California. So looking at the imagery, we see that that peak complexity in that second image there shows that something's happening there. So it's a time series near Lake Tahoe. The growth season is occurring. The complexity is the region of densest foliage, and it's much higher than the surrounding or previous and post imagery associated with that. So it shows you that something's happening within that area. So depending on the data, it will tell you that there's excessive dryness occurring, even excessive moisture. So you really got to go dig in with other types of data sets, but it kind of shows the complexity of the region to give you your attention to that region, that something's about to happen or something is happening. Next slide. We took some C-band radar data for the period before the Hermit wildfire and showing the radar scan complexity. You can see going from November to January to March, things are starting to happen. And by March, it's pinpointing areas of the largest complexity and the next level of complexity there. And combining that with the Sentinel-1 C-band radar into one image, it really tells us a story about that area, and in terms of how complex the region is, of course, but in terms of putting other data in there, in terms of moisture, foliage dryness, things that are happening within the region, you can see that was an area at risk, and it became, of course, a very large fire, which was started by prescribed fire. But certainly, even going in for prescribed burns, you really need to understand the areas that are highest risk, where to go in and do the burns, but also to understand that it could be a kindling of something really to start if you started doing those burns, and they would get out of control. What else can I say about this? It was a single step, and the overall changes go back to the radar data. The ellipses, of course, showing that complexity area, and things that are about to happen there that you need to put your attention to. Next slide. So we looked at some LiDAR data of the same region and showed the complexity of the region itself. Now this showing, of course, in the red area where it's a highly complex region, and in the green circled area, that's low complexity. So that's probably a water body that's associated with that. But any type of data can be put into this analysis when you're working from LiDAR, you're working from MODIS data, you're working from any type of geostationary, going down to polar orbiting satellite data, of course, MODIS, and even getting to the lower level sensor data from aircraft to show the complexity of the data that you're collecting and what could be happening and what areas you need to pay attention to. Of course, very useful for pre-fire planning, certainly very useful for active fire and post-fire analysis too, when you're looking at things like landslide potential. Next slide. Putting that all to a system we talked about in terms of previously in collaborating with Dave Jones and GeoCollaborate, we put together a solution here, how we can, starting from the databases, working with our company Coverse, which does a lot of artificial intelligence too, but also does the artificial intuition and the QCM and supports us there, and putting that into a data system that can be the analytics put out and sent to the end user. I'm going to talk a little bit more about this in a second in terms of other solutions we're going to have with we're thinking about with artificial intuition, and we want to do with in terms of the term sensor web. So we go to the next slide. You'll see what we saw the last time with Dave Jones and putting this data up on GeoCollaborate, where you have that place where you can put this data set and share it, disparate data sets shared with the disparate communities. It's active, it's real time. There's things we're talking about in terms of solutions to improve communications through portable cell phone towers, and also satellite communications to be able to get this data to the field where the tactical and firefighter can see this data and respond to it to protect life and property, as well as the crews themselves that are out there fighting in the field, and get better communication. So we know a lot about GeoCollaborate. Of course, Dave Jones is online, and he's done some great things, but he's a partner in the things that we're doing here in terms of getting it to the decision makers. Next slide. What we're also proposing, of course, is related to drone capabilities. When we talk about a sensor web, which is a term that's been used at NASA for the past 20 years, we're proposing a product that's a sensor web prototype for integrating drones into response, or SPIDER. Now, this image on the right is an old image, but it gives you the concept. I think Karen Moe put this in a publication. If you know Karen from years back working at Goddard Space Flight Center, getting down to where the analyst is looking at the data, this is where we're seeing that we have the ability for the artificial intuition to steer drones in terms of where they need to go, what they need to image, and the areas of criticality they need to fly to. So we have this capability through our CUAS, our defense UAS systems, counter UAS systems that we develop for the military. They use the same type of technique, the artificial intelligence or artificial intuition, put into the drone to help steer that to an area of risk in the battlefield. But we're trying to apply this and want to apply this to drones for wildfire response in a sensor web capability. Next slide. Switching gears a little bit here, we've established a partnership with George Mason University, which is well known for eastern fires. I worked with them many years ago, John Q, who's still there at George Mason. But they're helping us in a number of areas in the wildfire application. And of course, a partner that we're going after a few solicitations with the National Science Foundation and others. But we're proposing a workshop, and I spoke a little bit about this, or we discovered this at the last TFRSAC meeting, where there was tremendous amount of research going on in artificial intelligence and machine learning. But there's also the lack of understanding that how close are these applications to operations? Sorry about that. How close are these applications to the operational use and going out to the decision makers? So we're proposing a workshop to bring together the artificial intelligence and machine learning researchers in developing those applications. And the goal is to advance the research to operations. We don't want the researchers to be in a continuing space of research and not moving that to operations. We want to accelerate that, and of course understand in terms of their research. And that goes back to the NASA applications readiness level system and how that measures what the application is in terms of its readiness for operations and going out and actually being used by the decision makers, by the stakeholders. So I'm looking for your feedback within this. As an AI and ML developer, do you think your system is ready or close to really an application level? How can we get together through this workshop, discuss these AI and ML solutions, and also see how we can apply artificial intuition to support AI and ML, but to move these into more operational posture so that they get out to the users? And go to the next slide. And the time of the workshop is to be determined. We're still working out the details for that, whether it's going to be in person or virtual. We'd like it to be in person. But if this chart here, of course, is just a section of the ARL levels, and we're looking at starting from ARL 6, anything ARL 6 and above. If your research is in that realm or close to that, even in a very high level ARL 5, we like to consider this to be a participant in the workshop so that we can help move that more into operations. And of course, I know when David Green is working, you know, I was the disaster manager back at NASA headquarters a few years ago, working with Vince and Everett for many, many years on this, but we want to get these things into operations as quickly as we can. And this may be a way to do that, picking up the promising AI and ML research that's underway and how we can help stimulate that, working with the community, and of course the requirements of the wildfire community to get this into operations in an experimental, even if we can get to the experimental phase, that's going to be very helpful in getting those products out to users so they can start learning and using these capabilities that have been sitting in research for a long time. So we want to accelerate that. Next slide. And another technique that's useful, and we heard from Vanessa Escobar in her tabletop exercise, we've got a thing called analytical gaming, which is a little bit different than tabletop exercising, but it's used to improve collaboration, cooperation, and communication. And it gets into a very intense type of, very, very different than a tabletop exercise. We just performed one called climate geoengineering, which was a global exercise that an agency asked us to do, and I can't give you any more details than that. But it was, what if a country was to do something that impacted climate change through a solar type of injection into the atmosphere of some chemical that reduced solar insulation. So we can do these in terms of the wildfire capabilities and bringing in the larger community, going from the top, from of course the data providers, all the way down to the field and the users of that data to take in that actionable information. So we're proposing, you know, a gaming event, and we really need your help to design this event and what it's going to look like, who's going to be involved. The one that we recently did had over 60 people involved in it, so it was a pretty large event, and it was all in person, and it was a 3-day event. And so it's a little bit different than the tabletop exercise, but really gets into the interactions and the cooperation and collaboration issues that may be occurring within the wildfire community. Next slide, please. Okay. And another thing that we have that we developed for DoD is called a virtual tactical assistant. You see the image down there in terms of the command post, the cloud, the UAS drone, the tactical vehicle, and the tactical virtual assistant, the person in the field. Just imagine this image as the command post, for instance, being the NIFC, the cloud, of course, being a cloud system, and of course a drone being a drone system, and a tactical vehicle. We also have some thoughts in terms of what we designed already for DoD for tactical vehicles that the Forest Service and others can use in the field for communications, satellite communications, holding a vast amount of data, providing radio communications as well as cellular communications in a portable unit that can drive through some pretty rough terrain. And of course, the tactical assistant, of course, the person or the firefighter or the incident commander can have this capability, which is a virtual reality type of headset. They can see and see where everybody is at. The firefighters can have sensors on board, and through radio communications, it will tell them where the firefighter is at. And it's interoperable, improves the situational awareness, hardware independent, and we think this is this could be a pretty good solution. See, I got about a minute left. Next slide. So we put it together in terms of what this would look like in terms of the Forest Service, and with this, call it the Forest Service C2, working from the cloud, working from the airborne and satellite capabilities, going down to the land vehicles, to the data links. Of course, GeoCollaborate could be a part of this because now you have that capability to bring a large amount of data into the system and put it on an iPad that an incident commander can be holding to see live data of what's happening in real time. It uses this LoRaWAN capability, which has been talked about as being a replacement for 5G. or an addition to 5G through radio communications and being able to transmit the data and to the firefighter in the field. Next slide. And this is the picture of the wearable edge compute hardware that the commander would be holding. Very light, uses very little data, very little power to be able to communicate this information to the firefighters. And pretty inexpensive too. This is not an expensive unit to develop, and it's already been designed for our DoD customer. Next slide. And part of that is our CloudSend Edge capability, the Internet of Things, in terms of, you know, the person, the vehicle, the facility, the sensors that are involved in that, and that includes the sensors on drones and other types of platforms, the communications, of course, the LoRaWAN and the IT networks, how you put that into machine learning, AI, IT, IoT services, applications, goes into the cloud. Comes down to the situational awareness and communications, down to the visualization to the person in the field, or the commander in the field, or even the wherever you're set up in terms of the firefighting coordination. So very useful, we think, using CloudSend. This is our cloud technologies that we have been very well developed and has been proposed to many and used by many different federal customers. And that's it. Thank you.
Great, thank you so much for another informative talk. Unfortunately, we're at time, so in the interest of keeping things on track, we'll move along. There are a couple of questions in the chat, but I think your co-authors have done a great job of staying on top of those. So I think most of them are addressed, but if you wanted to peruse them and potentially add any additional comment, that would be great. So our next speaker is Joseph Sexton. Could you do a quick sound check for us, please?
Yep, can you hear me?
Yes, we can hear you loud and clear. And he will be presenting high-resolution, annually updated maps of fire risk based on satellite and meteorological data. So take it away, and I will give you a 2-minute warning with the camera.
And I'm going to share my screen. Is that okay?
That's fine,
yes.
Everett?
Yep.
Okay.
Okay. Give me a second to make that happen. Are you seeing my screen?
Yes.
Yes.
Okay, good. Then
I
start
see a
off with
map of North America.
Yep. All right. Now I just got to get my PowerPoint to. Okay, there we go. All right. So my name is Joe Sexton. I'm the chief scientist of TerraPulse. Well, if anyone remembers the Global Land Cover Facility at the University of Maryland, we are the modernization of that lab. Once Landsat became free, I joined the university. So I'm actually an ecologist. University of Florida, Utah State University, then Duke, all satellite remote sensing starting in 1998 when I saw my first GPS, GIS, and Landsat image while cruising timber at Tall Timbers Research Station. Kind of decided, if you've been ever in the panhandle of Florida in July, you're looking for anything as an opportunity. So in 2009, Landsat became free. The University of Maryland, Global Land Cover Facility, and NASA got a project to develop the world's first Landsat-based tree canopy cover and forest change map. I had just finished my PhD at Duke, developing methods to do exactly that. So I got hired. Those algorithms became the ones that produced the data set. We published the data in 2013, started the company in 2014, and we officially, we quit our jobs. We were officially retired in 2019. The work that I want to show you is some work that we're doing that's NASA funded. It's actually through the biodiversity program. It's in collaboration with the University of Michigan, Utah State University, Idaho Fish and Game, and the U.S. Forest Service and USGS, using EcoStress, Landsat, MODIS, Sentinel, like multi-sensor fusion for looking at how ecosystem stress propagates, or how stress propagates through food webs. And to me, fire is the ultimate herbivore. So that's what I'm going to talk about. This is 15 minutes is not a whole lot of time, so forgive me. I'm going to skip over a lot of technical details. Well, forgive me again. We've had some really interesting talks on complexity. So I'm going to do great violence to the real universe and impose some definitions on it. So fire hazard, and these definitions are coming from Hardy 2001. Fire hazard is the probability of fire given fuel and terrain. Fire danger is also a probability, but on the right-hand side of the equation, it's fuel, terrain, and weather. Fire exposure is the probability of fire times the natural resource, or an asset value if you're thinking more financially. So the natural resource that I'll be talking about and that we are mapping using Landsat, Sentinel, MODIS, and JEDI is biomass. So that's the probability of fire times biomass. And then fire severity is just the change in that natural resource over time. We're used to thinking of fire severity in terms of the difference in the normalized difference burn ratio. That is, in my opinion, that's something that's been imposed by a limitation of the data that we've now overcome. We can be looking at fire severity in terms of tree canopy cover, in terms of biomass. I mean, in terms of mule deer habitat, if you want. Given those definitions, and given the remote sensing assets that with which this group is very well familiar, this is a fairly well posed estimation problem. The probability of fire in space and time is the expectation of the relative frequency of fire given the conditions. Now, what this is not is a simulation model. We are not doing, I'm not talking in this case about spread. That would add much more complexity to that right-hand side of the equation. But for those of you that are doing that, the fuels data that I'm going to be showing are highly applicable to those fire spread models. A lot of the impetus for what I'm about to show has come from conversations with insurance agencies and the like, where they are doing, they need information, and they are running models similar to, probably very similar to what TechnoSilva is running, if TechnoSilva isn't even not the ones running it for them. And they just need consistent data over time in order to train and then predict those models. So even though it's a well-posed estimation problem, that doesn't mean it's an easy one. And the problem is obviously getting the data. We need fire history, we need the terrain, we need the weather, and we need the fuel, the left-hand side and the right-hand sides of the equation. Now, in order to train a model and not have an overfit model. So if you train on, say, 1 year of, you get terrain, weather, and fuel, really good data for 1 year, your model's going to be overfit. And if you try to predict that, you're going to have a lot of unincorporated variation in your model. And from 1 year to the next, that model's those predictions are going to be swinging wildly. It's not going to be very useful. So what we need are temporally coincident, or in the case of fire, because fire is changing the conditions that create it, antecedent data, which means we need time series. It needs to be spatially complete, and it needs to be statistically consistent over time. So what I'm going to do, and this is, I'm going to show you what we are providing. So on that right-hand side of the equation are variables like tree cover. This is Sentinel-based tree canopy cover, annual going back through the span of Sentinel. We've got 2017 to 2021. You can see I'm doing the Eastern United States now just because it has nice gradients of tree canopy cover. Power lines, roads, wildland urban interfaces, all really nicely captured in these data. And it's over time. So the way that we are estimating these tree canopy cover percentages, it is a probability density function in each pixel. So change detection also becomes we're not mapping tree canopy cover in time 1, mapping tree canopy cover in time 2, and then only doing a what's called an image differencing. This is basically a t-test over time. So we're taking the root mean squared error as the standard deviation of the distribution, the expectation, the estimate as the mean, and then performing time serial significance tests. And this gives us losses of forest over time. You can see harvests. If I go down to, say, the Apalachicola National Forest, might be missing the forest precisely, but the region. If you take a vegetation index, this is all available via the API. So we're working with a lot of different scientists. You see that this was a pine forest with a slight deciduous fraction backward to 2000. This is MODIS NBAR data product. Looks like the clearing happened in 2018. Got an herbaceous flush in 2019, and then it's on its path to recovery in 2020. Moving over to some more flammable ecosystems. We've got the Carr fire, the cabin fire. Here's the North Complex fire, all showing those forest losses. Up the coast, this is the tree canopy cover. Let's get rid of that. At different times, we're getting really good signals now from the optical sensors just by the data density of Landsat and Sentinel on this. We can break this. We don't try to do species. Instead, we're looking at evergreen fractions, deciduous fractions. Let's go back over and show the place where there's some better evergreen deciduous gradients. So there's the bottomland hardwood forests of the southeastern United States, the upland pine plantations. Mining that all the way backward through time, we can get disturbance histories. So this forest loss 2010 to 2015 would be 1 year of that, but forest loss all the way backward gives us this is the map of the most recent significant forest loss. You can tell 1994 is yellow in the heat map. That's the Pacific Northwest Forest Plan. Spotted owl got listed. All the forestry basically moved out to the state and private timberlands. Running that algorithm backward gives us forest gain, and we can grab for basically arbitrary regions. That's an age class distribution over an area the size of a county in Washington State. Now, those data, and I'm going to show you, moving on to biomass and fire, those data trained on JEDI in this case gives us maps of biomass that are very consistent from 1 year to the next. That's kind of an important thing to be looking for just as a giggle test when you're looking at these data. So biomass, remember I talked about exposure and risk. Then similarly to how we're taking this entire time serial data cube and predicting biomass using whatever training data that we can access. JEDI is the one, and if we have partners who bring their own training data for biomass, then we can do a calibration for that. Then mapping wildfire danger. Let's danger, hazard. Remember those equations that I gave. The hazard is the probability of fire at any point in time. This is for each year, given fuels and terrain. If we incorporate the meteorology, we're using the fire weather index, multiply that danger by by the biomass value, and this gives us an estimate of the resource at risk. And my internet connection is going to slow down and not show the true resolution of that data set for me. Anyway, severity, if I pull out the MODIS active fire data, if I can find one in the image here, I might not be able to find one right now. Let's just do this. If we pull out the active fire data for any point in time, the severity is the biomass value in the year before subtracted from the biomass value in the year after. And all this is trained on right now as the basic, similarly to how we use JEDI, is trained on the MODIS burned area and active fire. So the way that our partners are accessing these data, we deliver them in 3 ways. The SFTP for kind of the old school people who just want the data brick to mine as they see fit. For the more modern way, application programming interface, it works in R, it works in Python, and then through this really simple TerraView monitoring interface. It's not so much I would not, in this crowd, I would definitely not call it a monitoring interface. It's more of monitoring your own data, quality control checking, and exploring your data. The applications, as I opened with, we're using it for very, very simple risk mapping. You see academic papers coming out where they say, the amount of fire or that eco-stress shows that is a precursor to wildland fire likelihood, those sorts of things. But for this crowd, I think it's equally interesting as covariates for the more complex simulation-based models. And with that, I just want to kind of introduce TerraPulse, introduce myself to the crowd, and just say that we're open for partnerships and I can take questions.
Thank you very much for your talk. We appreciate it. Everett, I think I interrupted you.
I don't think so.
Oh, okay. Thought I heard something. Your circle lit up for me. I don't see any questions in the chat, but we can keep monitoring those if something does come up. But I think, again, in the interest of time, we'll keep moving on to our final speaker of our block, and that would be Karen Ann. And she's going to be speaking about the application of SAR products for wildfire response and monitoring. And I think Everett has your slides.
Should see that. You should see them now.
And there they are.
Thanks, Joe. That was great. I really appreciated that presentation.
All right, Karen, it's all yours, and I will give you a 2-minute warning with the camera.
Okay, thank you. Can you hear me okay?
Yes, we can hear you fine.
Okay, thanks. Yeah, so my name's Karen, and I'm a postdoc currently at JPL with my mentors listed here. And today I'll be speaking about the application of some SAR products for wildfire response and monitoring. Next slide, please. So today I'll be showing some data sets from the UAV SAR instrument. This is an airborne radar from NASA, and it is a long wavelength L-band frequency, which allows for further penetration through vegetation with more direct returns from the surface. And it has a high spatial resolution, about 6 meters on the ground, for its products that allow for detection of detailed features such as vegetation changes and fire scars. UAV SAR has been flying since about 2008 with repeat acquisitions over several study areas around the world, and the data is free to use. Oh, sorry, can you go back one?
Yeah, I don't know if I did that or whether it advanced automatically. Sorry.
Oh, sorry, it's okay. And since it's airborne, it can potentially be deployed within hours of a disaster event. So in contrast to optical images, sorry, maybe I have the setting where it will move on its own. But in contrast to optical imagery, radar can see through smoke, haze, and clouds and can image the surface day or night. So in today's talk, in the upper right-hand corner, I'll have some flags for during what part of the fire cycle that I think the data sets could be useful for. So look out for those in the upper right. Next slide, please. So actually, Vanessa earlier today kind of introduced the Bobcat fire that occurred in Southern California. And here we're looking actually 2 years before the fire occurred in 2018. So here we're looking at a SAR parameter called HV, which is a proxy for healthy vegetation. So in this map, the gray areas are actually masked out due to radar terrain shadow. Areas in orange and red show low vegetation in a lot of places because of past fires in the black outlines. Areas in green and blue show more vegetation, possibly more fuel available to burn, and we see that within the white Bobcat fire perimeter. So again, this image is 2 years before the fire has occurred. Next slide. And here we're zooming in on the southern portion of the Bobcat fire. So we actually collected data during the fire, and this is a difference image of the previous 2018 image minus September 2020. So here green shows areas that are relatively unchanged between these two dates, and orange and red show the areas that have started burning during Bobcat fire. We also capture at the bottom here another fire called Ranch 2 that occurred in August 2020. And so it's captured because it's contained within the 2 time periods. So here that's that same figure, and we can compare it to this burn severity map. This is from Bayer, and it's based on optical imagery from Sentinel-2. So the orange and red areas show moderate and high burn severity. I'm sorry about all these
That's okay. I'll keep an eye on it.
Okay, I'm sorry. So comparing the burn severity and these burned areas in our SAR image, they seem to match well. Next slide, please. This is another difference image, but now it's September 2020 minus October 2020. So we'll only see areas that have lost vegetation during these 2 months. Shown up in the orange and red again. And if we compare this to a fire burn progression map released by fire agencies, we see that these 2 areas that pop up in our difference map in the circled areas, they actually are noted as having burned later in time from the fire progression map. Next slide. And finally, this is a last difference image of the first 2018 image minus May 2021. So this is now 5 to 6 months after the fire has concluded. And we see in the orange and red all the areas that have lost vegetation due to the Bobcat fire. And if you click next one more time, if we compare this to the final burn severity map, it matches very well in lots of places of the places that burned at the highest severity also lost a lot of vegetation. And using this kind of map from SAR data, we can also help to improve upon the fire perimeters. So there are some places, if you zoomed in, where it doesn't follow exactly where the fire perimeters are drawn. Next slide. So now a few GIS exercises. This one's looking at the relationship between burn severity and biomass. So on the left, we have that optical-based burn severity map, and we ask the question, within each of these burn polygons, what was the average HV value in 2018 before the fire? And we see in the image on the right that areas that burned at high severity in 2020 actually had higher vegetation in 2018, shown by the red areas. So again, HV, this is that proxy for vegetation. It's an indicator of healthy vegetation and can help show available fuels. So now a different exercise, but with burn progression. So on the far left, we have the burn progression perimeters released by fire agencies, where the fire first started in green, and as it moved to the yellow, orange, and red areas. And we asked a similar question within each of these progression polygons, what was the average HV value in 2018? In the middle image, we see that the areas that burned first in 2020 in the center had more vegetation in 2018. And the areas that burned later, for example, those two circled areas that we saw earlier, they actually have lower average vegetation in 2018. And then in the last image here, we asked within each of these progression polygons, what was the average slope value? We found that areas that burned first in 2020 in the center had on average a higher slope than the areas that burned later, such as in the circled examples. So a lot of factors, of course, can contribute to burn progression that I have listed here, but this is kind of a first take into seeing any patterns. So yeah, next slide. So I've shown a couple images, but we also, if we have continuous acquisitions, can track vegetation changes through time. So here we're looking at a different SAR parameter called alpha angle. And if you click next, as this value increases, we're seeing more vegetation. As it decreases, we're seeing less vegetation. So here we're looking at pixels within the Bobcat fire, and I've also masked them according to each of the different burn severity classes. And yeah, you can stay here. And so we see that the top line of high severity in the dark red, there was more vegetation than the other classes. But once the fire started burning, we see that large decrease in vegetation. So in the background here, I've also plotted the local wet and dry periods in Los Angeles County. So the wet periods in blue and the dry periods are in the purplish red. So we actually see a seasonal lag with the vegetation. For example, in 2010, 2011, during this wet period, we see this gradual increase in vegetation to this peak in the dry period, and then it starts to decrease over time during the drought years. So we can track vegetation changes through time, but there is a seasonal lag. Next. So now looking at a different fire. I'm sorry if you can hear the gardeners outside. This is the Caldor fire in Northern California. And here we actually collected data during the event. So there were 3 flights, and I took the difference between the first and last flight, about 1.75 hours apart. Those are the top 2 panels that you see here. So areas in red are showing the largest vegetation loss. And if we compare this to the bottom 2 panels, which are again from the Bayer soil burn severity product created after the fire, we can see that these features are quite similar in some of these high burn severity areas that are shown here. Next slide, please. And a different fire, this is the Woolsey fire in 2018 in Southern California. Here, we can use a different SAR parameter called interferometric SAR coherence. Coherence is a measure of how similar 2 SAR images are. Here we're looking at 2 images 36 days apart before and after the fire. High coherence in the blue and green means that very little change occurred between images, while low coherence in the orange and red means a large amount of surface change occurred. And here that's due to fire removing vegetation, and we can see those low coherence areas within the Woolsey fire perimeter. Next, please. And my last example here is from the LNU Lightning Complex fire. This is a damage proxy map from the ARIA team at JPL. And here they've used UAV SAR images before and after the LNU Complex fire to create this map. This map actually contains changes both from previous fires or from post-fire vegetation growth. So the yellow to red here doesn't mean that everything is actively burning. It's indicating increasingly more significant ground surface change. And that change can be either from vegetation growth from these past fires or vegetation loss, like from the LNU Complex fire. So this is kind of a popular product that is used, and we'd like to improve upon these types of products. Next. So to summarize what I've shown today with the polarimetric SAR, those were all the images in the beginning. I hope we've shown that it's possible to track fuel availability and vegetation changes over the entire fire cycle. With the interferometric SAR or NSAR, the coherence image can show detailed changes to the landscape and can be also used to generate damage proxy maps. As far as GIS goes, all the data sets shown here are GIS compatible. I work primarily within ArcGIS, and they can be modified to be ingested into any existing GIS platforms that may be used. UAV SAR can hopefully provide disaster response with these current snapshots of burn areas, but also aid fire management in between events. So looking at vegetation growth, regrowth after a fire, and also helping with fuel treatment planning before a fire. And lastly, UAV SAR is the airborne prototype for NISAR, which is the upcoming space satellite. So the products that you see today could be available for other areas globally. And next slide, please. Speaking of NISAR, a small plug for the NISAR Early Adopters Program. If you're interested in these types of data sets, we are looking for partners at fire agencies to develop workflows, tools, and data sets to help with wildfire monitoring. So if you're interested, I encourage you to contact me and also check out the website here that I'll link in the chat. Next. And here's my email, which I'll also put in the chat. Thank you.
Thank you, Karen, for that great talk. I think you gave us a different perspective on looking at post-fire impacts, which was really interesting. There is one question for you in the chat from Kristen Allison. Any chance you were able to share this with the forests?
Is that sharing with Forest Service people or
The data
That's
sets, Karen, that you showcased, I was wondering if you worked with them to validate some of the information you had, or you were able to share your end results with the forests?
No, so that's part of why we're looking for partners with the NISAR Early Adopter Program, is that so far the comparison has just been with optical data sets and like the fire perimeters that are publicly available.
Great. I don't see any more questions here, but if there are any more that trickle in, please go ahead and add them into the chat. And as has been indicated, this is all being recorded, so we'll be able to go back and have a record of this. And I believe with that, we have wrapped up the more formal portion of the afternoon block. Thank you again to all our presenters who presented this afternoon. And we are now into an open discussion and wrap up portion of the block.
Yeah, and I wanted to personally thank all our speakers. Great presentations today, lots of thought-provoking information there. I always learn something new at these meetings, and it's nice to see sort of this forward progression that we've been making over the years. And I grabbed during one of the breaks when someone else, I guess it was when Brian and Joaquin were presenting, I grabbed a couple slides from some of the earlier presentations. Let's see if I can get up here. When Zach Holder was on this morning, he mentioned data standards and interoperability and the importance of that. And that was actually, that was repeated, I believe, by Brian and Joaquin as well, how important interoperability is. Let's see if, okay. How do we communicate what the needs are? And, you know, as Zach and I mentioned this morning, having the requirements matrix for fire is, you know, we had that first version that came out a couple of years ago that was really good, but now we're in the process of, I say we, it's Zach and his team out there are in the process of reworking that and refining it based on feedback from people and including me. And you know, I think that that's really one of the important communication tools about what information do we need, what does it need to look like, And for different phases of fire, different people managing the fire are all going to have different information needs. And I think Brian Collins really kind of foot stomped that message as well, that, you know, different people on the same fire are going to have different information needs. You know, and we're sort of in this position now where, because the fire dynamics seem to be changing fairly rapidly, it's really hard to keep up with not only with fire behavior, but also the technology, because we have more opportunities to investigate than we have people to evaluate those opportunities and capabilities. But I really do feel like we need to change our agility and our ability to respond to new technology as it comes online. And, you know, a lot of that's sort of a core issue in federal government, is how do you effectively evaluate technology and work your way through the contracting process, well, the evaluation process, making sure that it's something that the end user needs, and then working your way through the procurement process to actually get that capability. I think it was Sean that I think I have Sean's slide up here actually. He mentioned the need to have something that's persistent. I don't remember exactly how he phrased. I don't know if Sean's still online, but you know, having a capability that comes out that's, you know, somewhat short-lived. Maybe it's something that goes up on the space station, you know, that has a very limited lifespan. But we need to invest in capabilities that have a long lifespan to them, so that we're not investing time, money, and energy into developing a capability that then very quickly goes away. So, okay, so reworking the fire requirements matrix. This is from David Green's presentation. There was lots of slides in David's that really kind of jumped out at me, but you know, he mentioned fire sense, and you know, detection and characterization of active fires are fundamental to supporting real-time applications for fire management and supply information on fire behavior and severity needed to advance fire science and applications. And, you know, really, the way that I've kind of focused on things over the years is that there's a certain amount of information that they need to have on the fire. It needs to be current, it needs to be accurate, it needs to be precise. And, you know, so I've looked at a lot of things over the years that are pretty cool, but the latency is just not acceptable, you know, or for whatever reason, it doesn't really fill a niche or a need in fire support. Let's see. So this is Sean. This is the one slide that I pulled from Sean's presentation. There's a lot of really good, dense information on this slide. You know, the tech needs to be available to boots on the ground. It needs to be integrated into the system, which means that, you know, that it needs to be ingestible by our common operating systems. It needs to be scalable, not just, it doesn't just work locally, but it can work nationally as well. So there's a lot of good, really good information on the slide here. This is from Brian and Joaquin's presentation. I really like this sort of challenge to the TFRSAC community. What is it that we can do to, you know, to foot stomp some of the important messages to academia, to other federal government agencies, to the vendor community? You'll see the word interoperability in there on every single bullet. So that's something that you know, that's kind of a key takeaway for me, is some of the comments on the slide here. And I think with that, I just wanted to kind of throw those up there as some food for thought and discussion. And I think this is a chance for, you know, Birgit and Vince, my co-chairs, and for everyone that's still on the call to, you know, raise your hand and turn on your mic and your camera if you have some thoughts that you'd like to share.
I'd say, yeah, we'd have people to raise their hands first rather than, you know, kind of blurting out any questions that they might have. So that way we can manage it a little bit better. Thanks, Everett. Great comments on the overall first stage program. And yeah, I too learn everything at these TFRSAC meetings, and that learning curve has gone back, you know, now 20 years for me. with the start of the first TFRSAC. One of the things I will point out, I didn't get a chance to do it earlier when Steve Ambrose spoke, was Steve mentioned that he had been the disaster program manager at NASA, and he was my first program manager when I was funded to do the early collaborative work between U.S. Forest Service and NASA in the use of unmanned vehicle systems, showcasing airborne data collection systems, geospatial data systems integration, and as that program manager of our collaborative wildfire project, Steve was also instrumental in being one of at the very first TFRSAC meeting back in 2003. So he goes back to our original TFRSAC meeting in, I think it was Baltimore, in conjunction with a conference we had in Baltimore. And so he was on the original TFRSAC committee meeting back those 20-something years ago. So, it's good to see him back in the fold. And I continue to chat with Steve periodically on the topic areas, and good to have him back in the fold again. So.
I see Ed Freeborn has his hand up.
Yeah, thanks, Vince. I really like this slide too. I suspect that I have had the SafeCom interoperability continuum in some of my briefs to TFRSAC. It's a really good multi-dimensional representation of interoperability, but this one really adds some additional dimensions to that, and I'd really be interested to see how they all mash up together. But yeah, I like this perspective.
And thanks for that, Ed. One of the things that I wanted to point out, I showed that sort of very simplified Venn diagram with the TFRSAC on the left and the thermal working group on the right. And there's a little bit of overlap there because there's a number of members that participate in both groups. And then we, obviously we need to have that connection to the fire community, and that's what the green ellipse was down below, capabilities development and integration. And that's people like Zach and Sean, and then, directly to the fire from there. But that's a little bit of an oversimplification, because even though, there's, we have the TFRSAC working the unclassified side of the fence and the thermal working group working the classified side of the fence, they're not really identical in the way that they're structured and the way that they work, because the thermal working group is a core group of people that is actively working together on specific tasks that are pretty limited in scope, but these are big ideas, like the development of the FireGuard program, Firefly FireGuard. And prior to that, the Hawkeye Fire Detection and Reporting Program. And prior to that, the Firehawk, which has been going on for 25, 26 years now. And so that the thermal working group is more of a working group that's actively, working with folks at NASIC and NGA and other places to figure out where the edges are, where we can leverage capabilities, and how we can work within the system, within the constraints of working with classified data, how we can leverage that to produce derivative products that we can throw over the wall in a timely way that are useful to people that are working fires. And the TFRSAC, on the other hand, is more of a community of practice, where it's basically a forum where we get together, share ideas and information, we look for opportunities. And hopefully the vendors that come to this meeting, people that are working in academia, they go back from these meetings with ideas about, hey, here's a place where the stuff that I'm doing fits into the needs that they have in the fire community. So they do work together. They're complementary, but structured slightly different. And I see Ivan Clark has your hand up.
Yes, thank you. I was having trouble unmuting. I apologize for not being here for the first part of the meeting, but I had fallen off the distribution list. What I saw was a lot of discussions about moisture-driven canopy and understory, which pretty much should track together. What I haven't seen and what I don't understand is what happens when you have canopy that has been insect killed. whether it's the ash trees up and down the Shenandoah Valley, the black walnut trees in Oregon, or the pines in Rocky Mountain National Park, where you have dead standing canopy with possibly rapidly growing understory. I don't quite understand how one does a fire risk management for that and how that would be mapped with what I'm seeing in terms of the sensors. Could you help me wrap my mind around that challenge?
I wonder if we have anyone from the fire lab in Missoula online, or anyone who may be able to take a stab at that. I see Joe Sexton has his hand up there.
If someone from the fire lab is here, just let me know. But as far as the remote sensing of that from the global sensors, talking Landsat, Sentinel, we can detect, well, depending on the cloud cover and the phenology, we can detect losses of canopy, tree canopy, within a year. I think the finest that we're able to do it, what we do is we estimate tree canopy cover in every pixel of every image that overpasses, and then we fuse them into multi-temporal composites. And the more images that we bring in, the variance shrinks, and eventually we get to the smallest variance in that pixel that allows us to do change detection. So our ability to detect that varies from one region to another. But in fire-prone regions, that's actually, it's a better condition because we get more cloud-free looks with the optical sensors. Obviously, if we're using SAR, it gets better still, but SAR doesn't work that well, at least in our algorithms, without an optical assist. So that's the tree canopy. We can see changes in tree canopy cover, and then we use phenology and, say, like daily MODIS or roughly weekly Sentinel NDVI. So we're not detecting vegetation types, like these big long legends of categorical variables. It's all continuous variables, and then the machine learning algorithms are flexible enough to recognize the relationships between those and the fire probability.
Yeah, thanks for that, Joe. And I'm going to add a little bit to that. One of the things that we developed at the Remote Sensing Application Center many years ago when I was there was something called the Forest Disturbance Mapper. And basically what we did was we took MODIS and the daily overpasses, and for every day of the year, the pixels were given a value and put into a library. Then they did like a 10-year average. As time went on, they built an average up to 10 years. And then when we started to see changes in those values beyond a certain threshold, we would mark those pixels. And we discovered that we were able to pick out things like bug kill and fires and hurricane damage along the coast where there's saline intrusion and tornado. We could see the tornado swaths. It's not very high resolution, but it's resolute enough that we could we could develop this library of standard pixels for every day of the year through the changes in green up and so forth, and then start to look for those changes in the variations due to things like bug kill and fire and those other physical phenomenon that I mentioned. It doesn't tell you what it is or what the species of the trees that are being affected, but as Joe mentioned, there's other ways to tease that information out once you realize that there's an area that's been disturbed. So I think that last comment came from Ian Clark, and I'll make sure that you get back on the mailing list.
Thank you. I sent you an email.
Okay, thank you very much.
And Dale has a very pertinent reply in the chat.
Okay, let me check here. I think I saw something about NNU there. Oh, Dale Hamilton, yes. And then you was able to identify beetle kill crown from hyperspatial SUAS imagery using deep learning. We're transitioning to very high resolution satellite imagery. We'll see how well the deep learning handles beetle kill trees in that imagery. Yeah, and there's a logical connection there between you have dead standing timber, that's basically fuel for the fires that are coming through. And we've had so much beetle killed trees in the western US. It's kind of mind boggling, really. But so I hope we kind of, between Joe and myself, we took a good stab at answering that question.
You did. Thank you.
Any other thoughts or questions before we close for the day? I'm actually going to jump over to another meeting to present on communities of practice, which I believe the TFRSAC is a really good example of that. Birgit or Vince, do you have any other closing thoughts before we start to transition to tomorrow's meeting?
Not really, just remind people that we're going to be starting same time tomorrow at 11 a.m. Eastern time, 8 a.m. Pacific time. And for those of you in other time zones, figure it out yourself.
And I do see Deepak has his hand up there.
Okay, let's shoot to him. That was about all I needed to say. And see if Birgit has anything to add after Deepak.
Hi, this is Dee. I was just wondering if there were any lessons to be learned from current events. In other words, if we treat the fire community as a small country that may be underfunded but facing extremely difficult, dire circumstances, whether we should be looking to see some Starlink assets in our future, some low-cost drones, and maybe some additional help from the DoD and the intelligence community a la Ukraine. Are there any lessons we can learn from people who are leveraging commercial technology to solve some really hard problems to fight wildfires?
Yeah, I think that's a really good point. And I think one of the things, I've been doing this for 20 years now, and for many years I've bemoaned the lack of funds and the lack of ability to really leverage some of these new capabilities that I see coming online. Vince and I have been looking at unmanned aircraft for nearly 2 decades in support to fire. And but there does seem to be sort of this understanding now that really fire is a really big problem. And we see this from the political community, that they're showing a lot more interest, being contacted by the PCAS, the President's Council on, I don't remember what the rest of the acronym is, but it's his advisors on scientific and technical issues. There's been a lot more interest from those groups high up in the federal government. And so it's clear to me that people recognize that there's a real problem here. And one of the things that I see being funded early on is, how do we reduce fire risk? Well, how do you determine where there's areas of risk? What are the high priority areas where you want to go in and reduce the risk by doing controlled burns and things like that? So there's a whole series of thoughts that are going on in terms of how do we reduce risk. And my approach and the approach of the TFRSAC and others through this whole process has been, what can we do to leverage remote sensing capabilities through the sensors, through the platforms, through communication, delivering data the last mile to get it into the hands of people that can use that data, making sure that it's in the context that it's useful to them so that they don't have to pick through different data sets and put them together themselves in order to come up with a comprehensive viewing picture of what's going on with the fire, because they don't have the time to deal with that. Fire is one of those things. You look at the Marshall Fire and how rapidly that fire was moving through that community. That's a real challenge to any kind of capabilities to be able to support the folks that are on the ground with any kind of actionable information in a tactical format. So we have really big challenges, but I really feel like that this forum that that we've developed over the past 20 years is a really good way to bring people together, figure out where the priorities are, figure out where the opportunities are, and then, work together to get the attention of people that can pay for capabilities, and then to work those into our data streams and information streams going to the people that are managing the fire. One of the things that we focused on in the last meeting was artificial intelligence and machine learning. I really feel like there's a big piece there in leveraging that capability to help with the information management, the data analysis, the information management, production of products, and delivery of those products to the people that can use them. Because we can't park enough people in front of computer screens to be able to handle all these different data streams that are coming in and get us someplace where we can, produce that information in a timely way for the people that need it. I see Mark Zoller has his hand up there.
Yes, hi, Everett, Mark here. Courtney Aviation. I wanted to contribute to that, answering that question in a different way. Yes, a lot of off-the-shelf commercial technology is being used, similar to what's maybe in Ukraine. We have a Manet network that basically ties everybody together on the network. We're using the Overwatch artificial intelligence data gathering to instantly, within 1 second of us capturing it, it's in the hands of the firefighters, the air attacks, the decision makers. Live video also, basically what you're talking about with a drone, but manned aircraft. The drones aren't really ready for wildfire. So that's all in my presentation, but that is off-the-shelf commercial stuff that is being used very aggressively for CAL FIRE.
Well, thanks, Mark. And we have posted your presentation to the portal where people can pull that down. Let's see. I saw David Green's hand up there.
Hey, Everett. Thank you. So I was just going to make a comment about, the way things are changing now, and certainly there's more resources and more attention. As I stepped out of TFRSAC middle of the day to go talk to another community of practice about wildfire, and this was actually something called WestFast, which is the water resources community for the Western states, who are concerned about bringing their science, technology, and capabilities from the water side and the watershed to the fireshed. And one of the things they said to me is, how do we break into discussions across our communities? And so one of the things I kind of talked about how NASA is trying to figure out that we've got to talk amongst our different programs, and we're using TFRSAC and others to build bridges internally and externally. Some of the discussions today talked about some subsequent engagements and workshops. I think one of the things we are going to have to prioritize is that some of these solutions and investments are going to come out of the fact that there are new opportunities to build these interdisciplinary groups. I might ask the TFRSAC, in terms of what can you do, also means perhaps reaching out to some of these other communities of practice,
right,
and offering to do some joint discussions on specifically where are there co-investments, new strategies for both public sector and private sector. So just put it out there. Thanks. Oh, and I'll just say for the fire effort, at AGU this year, I was approached by the insurance sector and the reinsurance sector to organize a session about modeling of fire-prone areas and bring the science and technology and the insurance sector together. So we're going to do that at AGU. So I'm just suggesting that we're in a prime time to build some bridges here, and TFRSAC could be a key player in doing that. Thanks.
Yeah, thanks, David. And actually, tomorrow there's going to be a presentation on the EIS, the Earth Information System, let's see, it's Kim Locke and others. The name escapes me at the moment, but bringing together people that are studying fire and hydrology together. Let's see, that was Sujay Kumar is going to give the presentation tomorrow, quantifying fire hydrology connections within the Earth Information System. So that's tomorrow in the second block tomorrow. So so that's a good point, David. Is that, you know, when it comes to a community of practice, where do you draw the edges, and when do you take advantage of opportunity to bring two of those communities together when there's common interests and common needs and problems to address. So let's see. I think since I have to jump over to another meeting and I'm running the portal here, that I may ask that we bring the meeting to a close. Vince or Birgit, any final thoughts before we close for the day?
I don't have anything to add. Thank you, Everett.
I second the vote to close. Yeah.
Oh, okay. All right. Well, thanks everybody, and please join back in tomorrow. We have another great day of presentations, and we actually.
Everett, can you clarify, just in case it becomes an issue, the same link tomorrow, right?
It's the same link tomorrow. Yes.
Okay, good.
So yeah, and I'll work overnight to make sure that everything gets posted in the online portal for the presentation so people can look at those. I think we have the lion's share of things that are already there. And so everyone have a good evening. Please come back tomorrow. Lots of great discussion. We do have 2 blocks of discussion time tomorrow, so we do have a little bit more time to talk tomorrow. So thanks everybody. Let's see, let me just post the online portal. There's a link at the bottom of the agenda. I'll also post it here. So let me just pull that up real quick here, and I'll drop it into the comments.
And then if we can capture the chat before you close it out.
Yeah, I'll do that for sure. Let's see. Actually, it's right here.
Just there's a pause there just for a second. I also wanted to acknowledge that there were a number of early career and students involved in the discussions today, and I think we need to acknowledge that that's really important part of the TFRSAC, and that we should really be promoting that next generation of leadership in the community. So the more we can really highlight this as an opportunity and that kind of career evolution, I think that's really important.
Yeah, I agree 100%. I was just at presented at a meeting of the PNT advisory board a couple weeks ago, the folks that address GPS issues, and I was there talking about the geodesy crisis that we're facing, where we don't have a lot of people going into that particular profession, and we need to have geodesists because that forms the basis for all the mapping that we do. And that kind of moved into a discussion about getting the younger generation, the kids that are in elementary school and middle school and high school, getting them interested in STEM careers, and how do we do a better job of getting kids interested in STEM. So there's another whole discussion there about bringing folks in, bringing young people in that are interested in science, making sure that they understand that there's a real need for people going into these professions. So
I was just going to make a play for that. If that next meeting is in fact in person, that we think about having a opportunity, a session where early career and graduate students and others can come and meet with some of the more professionals that have been around here for a while, perhaps do some mentoring, and take advantage of being an in-face meeting once again, if that's possible.
Yeah, I like that idea, David. I made a note of that. So, all right, well, I'm going to have to jump over to my other meeting and do another presentation. So everybody have a good evening, and I'll capture all the information needed here at some point.
Thanks, Everett.
Thank you.